everyone, for the given right triangle, we're going to find the value of sine of 15 degrees. All right, so here we have it. I had to draw it in here. It's a little sketch there. So what we're going to do is let this length of AD here equal B. So since B is going to equal that length, then we're going to look at this tan of 30. So there's your 30 degrees. So tan of 30 degrees equals opposite, that's going to be B, divided by CD. So this is your CD here, right here. So we'll write CD. All right. So for 30 degrees, this is a 30, 60, 90 triangle. So this length here is going to equal 1 divided by square root of 3. All right, because you're doing tan of 30. All right, so that means CD is going to equal square root of 3 times B. All right, now let's do cosine of 30 degrees. Now that's going to be CD divided by line segment AC. All right, so there's this one. That's your hypotenuse. So we're doing cosine of 30. So that's going to be, we know that cosine of 30 degrees is square root of 3 divided by 2. All right, therefore, AC is going to equal 2, if I cross multiply, 2 times the length of CD divided by square root of 3. But we already have CD here. CD is given here, so substitution, we're going to use 2, and it's going to be square root of 3B divided by square root of 3. And this all equals 2B, because the square root of 3's will cancel out. So you get 2B. Now, we also have this, this angle is twice this angle. So we're going to have the length of BC right here. Let me make my C a little better. This length equals the length of AC, this length here. Because remember, this is double. So this is AC, which equals 2 times B. Right? All right, because you have two triangles, and this angle is double the other. So if I took out the triangles, the smaller one has B, and that's 30 degrees. And if I do the bigger one, and this is 60 degrees, then this is going to be twice that, 2B. So there's that. And that means we have BD. This length here equals BC plus CD, right? Because we're adding these two together to get this whole length here. All right. So substituting that in, that's going to be the length of BC is 2B, and the length of CD is given here, square root of 3B. Okay, our goal is to find the length of AB. All right, so all we're going to do is use the distance formula since we have all our information. So for our distance formula, we're going to say the length of AB right here equals, and the distance formula would be square root of the segment BD squared plus the segment of AD squared. All right, so this is going to equal, when you use substitution, the square root of, now BD is going to be 2B plus square root of 3b squared. And then AD is just going, this one right here. Remember, we're just doing the distance formula or your Pythagorean theorem. So this is going to be plus b squared. Now, if I simplify this, I'm going to get the square root of, and I'm expanding this. So this is going to be 4b squared plus 4 square root of b squared plus 3b squared plus b squared. All right, and then we can group this all together and write this as equals to square root. I'm going to factor out a b squared. So this is going to end up being 8 plus 4 square root of 3 times b squared. Now the square root of b squared is just b, so let's pull that out. So we get b times the square root of 8 plus 4 square root of 3. Now, to do special factoring, what I'm going to do is rewrite this as, I'm going to put a 4 inside here. So I want to write this right here as 2 square root of 12. So basically what I'm doing is 2 times 3, and the square root of 4 is 2, and pulling it out. So we get back the same thing. So I'm going to write this as, and we're going to move on to another slide. So I'm going to write this as equals to b times the square root of 8 plus 2 square root of 12. Now I'm going to use my special factoring and write this as b square root. Write this as 6 plus 2. And then write this as 2 square root of 6 times 2. All right? So this follows this form of a squared plus b squared. Let's write it this way. A squared plus 2ab plus b squared equals a plus b squared. That's what I'm trying to do. So basically, I can rearrange this as 6 plus 2 square root of 6 times 2 plus 2. That means my a is square root of 6, and I'm looking at this, and my b is square root of 2, because I could write this as b times the square root of 6 squared plus 2 times square root of 6 times square root of 2 plus, and I'm going to move this up, plus square root of 2 squared. All right, so I'm just trying to make it look like that. Again, I'm going to rewrite this. A was square root of 6, and B is square root of 2. And then I'm going to condense it. So basically, all of that was just to write this as B times the square root of 6 plus square root of 2 squared, which is just going to equal B times square root of 6 plus square root of 2. All right, now let's get to our question. We have sine of 15 degrees. So that's going to be sine of 15 degrees equals AD divided by the length of AB. So using substitution, that's going to give you B divided by B times square root of 6 plus square root of 2. Now what happens is these b's cancel out, so that gives you 1 divided by square root of 6 plus square root of 2. And the last thing we have to do is rationalize our denominator. So let's do that. All right, now I don't have anything written here, but basically we just need this. So we're going to, we have 1, let's write it out here, sine of 15 degrees equals 1 divided by square root of 6 plus square root of 2. So to rationalize the denominator, you just multiply the denominator by square root of 6 minus square root of 2. But you also have to multiply the numerator by that. So that's going to be square root of 6 minus square root of 2. So the denominator just follows the form a plus b times a minus b, which gives you a squared minus b squared. That's just going to give you 6 minus 2. The numerator, we just have square root of 6 minus square root of 2. This equals 4, so our final answer is just going to equal, let's see, 1/4 times square root of 6 minus square root of 2. Thank you. Have a nice day. Bye-bye.